After defining the pushover load cases, we have to define the response spectrum as well. So response spectrum is required to find the performance point in our pushover curve. So for that, go to define and go to functions and click on response spectrum. So after that, you have to select the code. Here we'll select the Indian Standard Code 1893-2002, and you can select any other code that is followed in your country. Okay, so we'll select IS 1893-2002. After that, click on add new function, and we'll name the function as IS 1893 or 2002, or you can name it whatever you can remember, right? So seismic zone factor is 0.36 and soil type is 2 for medium soil. And after that, we'll so damping ratio is 5%, and we click on OK. So after that, again we click on OK. Hello friends, in this video we'll learn how to assign hinges to beams. Okay, let me first tell you what the hinges are. Suppose that these are our columns, okay, and this is the beam, right? So if this structure over here is under the cyclic loading, that is the earthquake loading, so in this situation there are points on this structure where the structure is likely to crack or yield. So these points are called as the hinges. Okay, so what are hinges? So hinges are those points on a structure where cracking or yielding is expected to occur under the earthquake loading or the cyclic loading. So these points are normally at a beam column junction. So right over here, and here and here. Okay, so if we got here also, if we got further columns, then we got 4 columns here, and for the beams here, and here also, right? So these hinges we have to assign to beams and columns in SAP 2000. It helps to study the plastic rotation of the building. Let's go to display first, and let's go to general options and click on standard and click on OK for the standard view. So after that, let's go to select and click on select and click on properties. We'll select all the beam members. So click on beam and select, okay, and close it. So after that, go to assign and click on frame and click on hinges. So hinge property over here, it will be auto. So relative distance. So what is the relative distance? So again, we'll draw a structure. So let me delete this one, delete it. Suppose that this is our ground and this is our column, this is another column, and this is our beam. Okay, all right, so like this. And so relative distance means that the software will consider this entire span as 1 meter. Okay, now it is asking us where you want to put the hinges. Okay, so we'll put the hinges at 5 mm from the face of the column here and 5 mm from the face of the column here. So for this point it's 5 mm, right? It's 5 mm, and from this point it's 950 mm. 950 mm, taking this face of the column as the reference. Okay, so relative distance 5 mm. Our unit over here is kilonewton meter centigrade. We can change it to something mm, right? So relative distance we give as 5 mm and click on add hinge. So from tables in ASC 41 to 13 and select a hinge. So we'll select concrete beams, flexural items. So degree of freedom, so M3 is the major moment, M2 is the minor moment. We'll go with the major moment, and V value from, so case combo will go with the gravity case. And transverse reinforcing, it is for the ductility detailing, and we'll go with this. And rest of the things you can keep them as they are, or over here you can change it to, so deformation control hinge load carrying capacity drops load after point E or is extrapolated after point E. So you can go with is extrapolated after point E. So after that we click on OK, and again we add another hinge, so that is at 950 mm, and click on add hinge. And here the same things are repeated, and we click on OK, and we click on OK. So now you can see the hinges have been defined at all these positions, right? All right, so this is how you assign hinges to the beams.